Hello everyone. So unlike the previous lecture, in this video lecture, we're going to dive deep into smart contract and try to understand it completely. Okay. Let's just go ahead with it. Overview. Smart contracts are the contracts that are coded and that are stored on the blockchain. They automate agreements between the creator, between the recipient, making them immutable, making them irreversible. The primary purpose, it is to automate the execution of an agreement without intermediaries, that is making it decentralized, ensuring that all parties can confirm to the conclusion instantly. Additionally, they can be programmed to initiate a workflow based on specific circumstances. It's like if the money has been transferred, these are the steps to be followed. So that is what it can be done here. Like if my flight is delayed, I need to get back my money because I was under an insurance. And that is what is the code that you write in the specific if and else block. So, a smart contract, also called crypto contract, is a computer program that directly and that automatically controls the transfer of digital assets between the parties under certain conditions. Obviously, it's like some conditions have to be met before you can actually, execute that code lines. A smart contract works in the same way as a traditional contract, but with a greater amount of reliability, while also automatically enforcing the contract. That is what I meant, right? Smart contracts are programs that execute exactly as they're set up, coded, programmed unambiguously by their creators. Just like a traditional contract is enforced by law, smart contracts are enforceable by code. Smart contracts are the fundamental building blocks of Ethereum's application layer. They are computer programs stored on the blockchain that follow if this, then that logic, right? You write in an if condition, okay, if this has been done, please do all these steps. And now it is unambiguous. If this is done, it has to follow all this. It's not human, it's not prone to errors in that way, right? If Alice won from Bob, I know that truth. Just ultimate that truth, right? I'm not going to make out my judgments that maybe she used some false practices. Nah, that is not my work to do. I am based only on the if and else conditions. The Bitcoin network was the first to use some sort of smart contract by by using them to transfer value from one person to another. The smart contract that was used in Bitcoin was actually just the normal basic condition to check, okay, if I'm sending money to you, I should have that much money that I am actually claiming to send to you, right? That says the smart contract involved employed basic conditions like checking if the amount of value to transfer is actually available in the sender account, right? And later we had Ethereum come up, the Ethereum platform emerged, which was considered more powerful because here I could write custom contracts. Why? Because the contracts were written in a Turing complete language. While on the other hand, my Bitcoin was written in a Turing incomplete language, which restricted the potential of smart contracts implementation. And then nowadays we have some common smart contract platforms, let's say Ethereum, Polkadot, Hyperledger Fabric, and many, many more. Then we have some features of smart contracts which go by distributed. Everyone on the network is guaranteed to have a copy of all the conditions of the smart contract and they cannot be changed by one of the parties. A smart contract is distributed by all the nodes connected to the network. Deterministic. If condition met, these are what has to be sequentially followed and you cannot change it. If I run a smart contract, you run a smart contract, in both ways we're going to get exactly same answer given the same condition is met. Smart contracts can only perform functions for which they're designed only when the required conditions are met. The final outcome will not vary no matter who executes the smart contract. Immutable. Once deployed, smart contract cannot be changed. Exactly, right? It can only be removed as long as the functionality is implemented previously. Autonomy. There is no third party involved. It's just me, it's just you executing the smart contract. We don't have a central authority. The contract is made by you and shared between the parties that you agreed to have it shared with. No intermediaries are involved, which minimizes bullying, which minimizes the granting of and also grants full authority to the dealing parties. Also, the smart contract is maintained and executed by all nodes of the network. thus removing all the controlling power from one party's hand. That is just decentralization. Customizable smart contracts have the ability for modification, or we can say customization, before being launched to do what the user wants it to do. It's also transparent because it's stored on a public distributed ledger called blockchain, due to which the code is visible to everyone, whether or not they are, participants in the smart contract. Trustless, these are not required by third parties to verify the integrity of the process or to check whether required conditions are met. Self-verifying and self-enforcing, right? Now coming to capabilities of the smart contracts, because no human, no error. Accuracy, they are accurate to the limit a programmer has coded them up to. Automation, can automate the tasks, processes that have been done manually. Speed, smart contracts use software code to automate tasks, thereby reducing the time it takes for the manual intervention, right, for the human interaction related processes. Backup, every node in the blockchain maintains the shared ledger, providing probably the best backup facility. Security, cryptography can make sure that the assets are safe, that the assets are sound. Even if someone breaks encryption, the hacker will have to modify all the blocks that come from the block which have been modified. We know all of this, right? The Merkle root and everything. And then we also have the hash to the previous hash. So if anything changes in the previous block, its hash is going to change. And that hash continued this block. This block is going to change this block, this block, this block, this block. And hence it's, a cascading thing. Capabilities inside, we also have savings. Smart contracts save money as they eliminate the presence of a central authority, they eliminate the presence of intermediaries in the process. Also, the money spent on the paperwork is minimal to zero. Manages information, smart contract manager uses agreements, store information about an application, let's say domain registration, membership records, etc. Multi-signature accounts. Smart contracts support multi-signature accounts to distribute funds as soon as all the parties involved confirm the agreement. How do smart contracts work? The important slide of this deck. A smart contract is just a digital contract with the security coding of the blockchain. It has details and permissions written in code that require an exact sequence of events to take place to trigger the agreement of the terms mentioned in the smart contract. So it's just step-by-step execution. It can also include the time constraints, making it have deadlines in the contract. Every smart contract has its address in the blockchain. The contract can be interacted with by using its address, presuming that the contract has been broadcasted on the network. I hope you're able to understand all this. It's just theoretical. What is the idea behind its working? It's pretty simple if-else statement. If you send object A, then the sum will be transferred to A, because if I'm selling up a commodity, it's like I'm selling up a commodity, I'm going to get money, right? And if you transfer a certain amount of digital assets, then the A object will be transferred to you. Now, if I'm giving money, I'll get object. Simple, right? If I'm giving some object, I will be paid money. Let's say in terms of crypto here. And if I am paying crypto, I'm getting commodity. Makes sense? And if I finish the work, that is incentivized. Then the digital assets mentioned in the contract will be transferred to me because I'm working. I'm working to keep the blockchain up. That is its incentive mechanism, right? The three steps: buying, selling, and the incentive ones, because they're working to keep the blockchain alive. How does a smart contract work? Starting with identifying the agreement, setting conditions, code business logic, encryption, blockchain technology, to making it to execution and processing to the network updates. Let's see one on each of the step one by one. First, identify agreement. Multiple parties identify the cooperative opportunity, and desired outcomes and agreements could include business processes, asset swaps, etc. Set conditions. Smart contracts could be initiated by parties themselves or when certain conditions are met, like financial market indices, events like GPS locations. If you reach this place, you're going to get this. If you're going to take this turn, you're going to get this. That is all. Code business logic, if condition is written. Okay, now I've decided the conditions. I have to write up a code, right? I have to write what should happen then if is met. Encryption and blockchain technology, making it more secure, secure authentication and transfer of messages. Execution and processing in blockchain iteration, whenever consensus is reached between the parties regarding authentication and verification, then the code is executed and the outcomes are memorialized for compliance and verification. Network updates. After smart contracts are executed, all the nodes on the network update their ledger to reflect the new state. Once the record is posted and verified on the blockchain network, it cannot be modified because it's only in the append state. New block can just be added. Previous blocks, I cannot do anything now. Nothing I can do with the previous blocks. Applications of the smart contracts: real estate. Reducing the money paid to the middleman, the broker, and distribute between the parties actually involved. The money that was actually being sent to the broker is now being divided between you and me because we are actually the parties involved in the transaction. Vehicle ownership: a smart contract can be deployed in a blockchain that keeps track of vehicle maintenance and ownership. The smart contract can, for example, enforce vehicle maintenance service every 6 months, failure of which will lead to suspension of driving license. Music industry. The music industry could record the ownership of music in a blockchain. A smart contract can be embedded in the blockchain and royalties can be credited to the owner's account when the song is being used for commercial purposes. I think it's just so simple. It's just go to read, right? Once government elections, once the votes are logged on the blockchain, it will be very hard to decrypt the voter address and modify the vote, leading to more confidence against the ill practices. Management. The blockchain application and management can streamline and automate many decisions that are taken late, that are taken deferred. Every decision is transparent and available to any party who has the authority. For example, a smart contract can be deployed to trigger the supply of raw materials when 10 tons of plastic bags are produced. It's just about what you want to be done in an if-else situation. Automating healthcare payment processes using smart contracts can prevent fraud. Every treatment is registered on the ledger, and in the end, the smart contract can calculate the sum of all the transactions. The patient can't be discharged from the hospital until the bill has been paid and can be coded in the smart contract, making it okay, you've paid and now you're free to leave. Advantages of smart contracts: record keeping. All contract transactions are kept in a chronological order, hierarchical order in the blockchain and can be accessed along with the complete audit trail. Right? Autonomy. Direct dealings between the parties, no central authority or no central party is needed. Reduce fraud. Fraudulent activity detection and reduction. Smart contracts are stored in the blockchain and you cannot do anything with the things that have already happened in the past. You cannot just forcefully modify it or make anything, right? So it's just reduces fraud. Fraud tolerance, same thing. Enhanced trust. Business agreements are automatically executed and enforced. There is no bias, there is no ambiguity involved. They're immutable and therefore unbreakable and undeniable. Cost efficiency: the application of smart contracts eliminates the need for intermediaries, brokers, lawyers, notaries, witnesses, etc., leading to reduced costs. Also eliminates paperwork, leading to paper saving and money saving. Last slide of this deck: challenges of smart contracts. Obviously, if there's so many pros to a thing, there have to be some cons, right? That is world. No regulations. A lack of international regulations focusing on blockchain technology makes these technologies difficult to oversee, difficult to implement. Smart contracts are also complicated to implement because though we have a lot of potential, we have a lot of market, we don't have enough skills for it, right? Because it's relatively a newer concept and research is still going on and to understand it fully, to make it available to the public fully. Immutable. They're practically immutable. Whenever there is a change that has to be incorporated in the contract, a new contract has to be made and implemented in the blockchain. You cannot just go in and amend the previous contract. That is out of the scope. Alignment. Smart contracts can speed the execution of the processes that span multiple parties, irrespective of the fact whether smart contracts are in alignment with all the parties' attention and understanding. So, if it's an if else condition, it just goes in, right? Whether I am ready or not, it does not even depend on that because it's automatic thing, right? If this if condition is met, the code will get executed irrespective of if I am ready or not, irrespective of my party if it is ready or not, because it's all automated, right? With this, we're going to take in the what are we going to take in next? Okay, anatomy of smart contracts that we're going to take in the next lecture. With this, I think we're good. If you have any doubts, if you want any reclarifications on any of the concepts that you think I just skipped, or I just spread fast across that, you can use the comment section. You can use the G forms attached. And if you like the video, if you were able to extract something out of the video, just go in, subscribe to the channel, because I'm getting more such videos and the playlist is still, stacking up. So thank you so much for listening. Bye bye.